Today we're going to investigate thermometry, but we're going to start off with a summary and look at kinetic-molecular theory, all matter made up of atoms, and we look at the particles that make up atoms, so it may well be molecules or ions, and the particles are in constant motion. In a solid, not very much, and in a gas, an awful lot. And what we're going to also look at a little bit about collisions as well. So the diagrams help. So the first box on the left, you've got a solid which has its own fixed shape, and the particles are just vibrating, some slight translational movement. And the middle diagram, the liquid takes the shape of the bottom of a container, and the particles are jiggling, vibrating a little bit more, some rotational, able to slide over each other. In the gas, the particles are far, far further apart than this diagram shows, moving randomly and colliding with each other in terms of an elastic collision. The particles aren't going to lose energy with those collisions. And in today's activity, you've got an uncalibrated thermometer. So we're actually heating up the thermometer, cooling it down, and we're looking at the liquid contained in it and the solid that is the stem and the bulb. We're using a thermometer with ethanol in it with a red dye. And as with any experiment, some safety. We're heating water to boiling, so care with hot objects, wearing goggles, gloves, apron. Care with glassware, which can be broken, and indeed the ice cold needs care as well. The lab setup, red tub on the left is the ice bath, and about 2/3 of the way along the bench you can see the metal cylinder, which is heated with the boiling water in it. So you're going to start off with your uncalibrated thermometer. It's got the alcohol in the bulb, it's risen up as far as it can at the temperature it's at, and you're going to draw around it to get an outline. And we have room temperature there, which we have no idea of its numerical value, but you are going to put on fixed values of temperatures at freezing point 0 degrees Celsius and boiling point 100 degrees Celsius for the levels that the alcohol gets to at those points. So your diagram, you're actually going to draw on those levels. So because a thermometer changes levels as the temperature changes, we're going to mark them with a tiny rubber band wrapped tightly round the top, and then we're going to put the thermometer bulb in boiling water until it doesn't rise the level of the alcohol in the stem until it's fixed. And you just move the rubber band to that height so you've marked it. Also try and see if you're holding it in the steam above, does that give a different value and why? So the best value you're going to repeat twice, take it out, let the alcohol level drop, and either put it in the steam or in the water to confirm your level. And you're going to take the thermometer out of the boiling water, steam again, and you're going to put a second elastic band tightly around the thermometer stem below the first one. Don't move the first one because that's your boiling temperature. So after about a minute or so, you're going to put it in an ice water mix that's already been left to reach freezing point for 10 or more minutes. So you know it's going to be 0 degrees Celsius. And let the alcohol level drop to the fixed amount, the lowest level, and move that lower elastic band down to the bottom there. Do that twice again, and then you've got your 2 fixed points, but as you take it out of the ice water, you realize that the alcohol level is going to rise again. Why do you only need 2 points? And then, so you're going to mark room temperature, ice bath temperature, and put those on your outline, because those are the ones we're going to work on. And then you're actually going to use those fixed temperatures of the boiling point level and freezing point level to actually work out what room temperature was on that particular day, and write it down, because that's part of your experimental results. What other temperatures could you add to the calibrated thermometer? And you might want to do that as well. And then here's one set of results, and then we go on to some questions. So you'll have to pause these, and we're talking about glass not being a good conductor, and questioning what's happening, and then why does the alcohol move up and down the tube with changing temperatures, and here looking at the arrangement of the particles at different temperatures and some questions with those. And then a summary of the lab sheets, and then the physics glossary and some of the words, but you can add to the glossary and your own words to make sure that you know the rest. And with many thanks to Washington International School, WIS Team Science, and Mr. Godwin's IB Physics class.